This is Section 5.2, Part B, Two-Way Tables and Probability. Students in a college statistics class want to find out how common it is for young adults to have their ears pierced. They record data on two variables, gender and whether the students had their ears pierced. For all 178 people in the class, the two-way table below displays the data. Suppose we choose a student from the class at random. What's the probability that the student has pierced ears? So if we look at the table, the total number of students who do have their ears pierced is 103 out of the total number of students, which is 178. So the probability that they have pierced ears is 103 out of 178, or if we want to write that as a decimal, we could say it's approximately 0.58, or about 58% of the class. Suppose we choose a student from the class at random. What's the probability the student is a male with pierced ears? So out of the entire class, we still have 178 students. And now we're just looking at males with pierced ears, which is 19 of those students. So 19 out of 178 will give us about 11% of the students. So there's 11% chance that we will randomly select a student, and it will be a male student who has pierced ears. This time, what's the probability that it is a male or has pierced ears? So the male students are all here, and the students that have pierced ears are here. If you notice that 19 is covered in both categories. So we're just going to add the three numbers that fit into those categories together. And 19 plus 71 plus 84 is going to have us have 174 out of the 178 students. And so the probability of randomly selecting a student and they are either male or have pierced ears is 98%. But you may notice that these events are no longer mutually exclusive. It is possible that the student is male and has pierced ears. So the use of the word or in probability questions is different than in everyday life. And if you say, I'll either watch a movie or go to the football game, this means you're going to do one thing or the other, but you cannot do both. In statistics class, A or B can mean one or the other or both events together. We can't use the addition rule for mutually exclusive events unless two events have no outcomes in common. So if these are no longer mutually exclusive events, and it is possible that A and B are two events that result in some chance process that overlap, then the probability of A or B is the probability of A plus the probability of B minus the probability that it is in both events. We do this so we don't count those people who are in A and B in both the category of A and the category of B. A standard deck of playing cards with the jokers removed contains 52 cards in 4 suits: clubs, diamonds, hearts, and spades. Each suit has 13 cards with denominations ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, and king. The jack, queen, and king are referred to as face cards. Imagine that we shuffle the deck thoroughly and deal one card. Let's define event A as getting a face card and B as getting a head. We need to make a two-way table that displays the sample space. So if we make our two-way table, they can either be a head, they can either be a heart or not a heart, and they can either have a face card or not have a face card. Now, out of the 52 cards, 12 of them are face cards. We have 3 that are hearts, 3 that are clubs, 3 that are spades, and 3 that are diamonds. So there are 3 that were hearts, and there are 9 face cards that are not hearts. Now we know that each suit has 13 cards. And if 3 of them are face cards, that means we have 10 hearts that are not face cards. And out of the 52 cards, there are 30 others, 10 from each of the remaining suits, that would not be face cards. So here is our two-way table that displays our sample space. Find the probability of A and B. So the probability that it is a heart and a face card is where those two categories meet, and that's just 3 out of 52. Explain why the probability of A or B is not equal to the probability of A plus the probability of B. And then we need to actually find the answer. So if we come back here to our sample space, the probability of A or B if we just took everything in event A, which would be all of the hearts, which is 13 out of 52, and then the probability of event B, which is all the face cards, which is 12 out of 52, then we would get 25 out of 52. But if you notice, we have circled this 3 twice. This means it has been counted in both categories. So we cannot just do A plus B, because it's possible for a card to be both a face card and a heart. So these are not mutually exclusive events. So this is why for the probability of A or B, we have to do the probability of event A plus the probability of event B, and then we have to subtract out the probability of A and B. That way we don't count it twice. So the probability that it is a heart is 13 out of 52. The probability that it's a face card is 12 out of 52. And the probability that it's in both categories is 3 out of 52. And we have to subtract that away. And this would give us a total of 22 out of 52. And if we were just to add the values together that are in those categories, we would get 22 as our answer.